Why is aliasing a problem in ADC systems? Imagine trying to listen to a song, but some of the notes are so high that your ears can't tell if they are really high or just sounds that got mixed up. That's what happens in an analog to digital converter system when aliasing occurs. When you convert an analog signal into digital data, you need to sample it at specific intervals. If you don't sample fast enough, the high-frequency parts of the signal can get mixed up and appear as lower frequencies. This is called aliasing. It's like a musical note that sounds like a different note because of how it was recorded. The main reason aliasing is a problem is because it causes distortion. When the high-frequency signals fold into lower frequencies, the digital output no longer shows the true original signal. This makes it impossible to accurately analyze or reconstruct what the original analog signal was. For example, if you're measuring a sensor signal that has fast changes, aliasing can make it look like the signal is slow or distorted. That can lead to wrong decisions or faulty system operation. To understand why this happens, think about the Nyquist theorem. It says you need to sample at least twice as fast as the highest frequency in your signal. If you don't, the high-frequency signals will appear as lower frequencies in your digital data. For example, if you have a 6 Hz sine wave and sample it at 7 samples per second, the Nyquist frequency is 3.5 Hz. Since 6 Hz is above 3.5 Hz, it will be misrepresented as a lower frequency, maybe 1 Hz or even 8 Hz, which causes confusion. That's why engineers use anti-aliasing filters before the ADC. These are low-pass filters that block signals above the Nyquist frequency. They help ensure only the frequencies that can be accurately sampled reach the converter. But no filter is perfect. Some high-frequency signals might still sneak through, causing a little aliasing. That's why designing these filters involves balancing complexity, cost, and how much aliasing can be tolerated. In embedded systems and digital electronics, avoiding aliasing is very important. If aliasing occurs, sensor readings can be wrong, control systems might malfunction, and data processing can be compromised. That's why understanding how aliasing happens and how to prevent it is a key part of designing reliable data acquisition systems. In short, aliasing causes high-frequency signals to look like lower frequencies in digital data. This leads to errors, distortion, and unreliable measurements. Using proper sampling rates and anti-aliasing filters helps keep the digital representation true to the original analog signal, making sure your system works accurately and smoothly.